So today we're going to be adding rational numbers. Our essential question is, how can you use what you know about adding integers to add rational numbers? So today we're going to be working with rational numbers, and we need to remember that rational numbers are any number that we can turn into a fraction. So that's going to be any decimal that either comes to an end or has a repeating pattern, or any number like an integer or a whole number which we can turn into a fraction by placing over 1. So our goals for today are going to be adding those rational numbers, getting some extra practice with those rules, and solving some real-life problems involving rational numbers. So we're going to be adding and subtracting rational numbers. Okay, so in words, what they want us to know is to add or subtract rational numbers, we're going to use the same rules for signs as we used for integers. So we remember from our previous videos that when we are adding integers with the same sign, what we're doing is we are adding the absolute values of those integers and then using the common sign. So if we had 2 plus 5, that means we're a positive plus a positive. 2 plus 5 is going to be positive 7. Okay, and then negative 2 plus negative 5, we have a negative plus a negative, so our answer is going to be negative, and that means we have a negative 7. And then again, adding integers with different signs, we're going to subtract the lesser absolute value from the greater absolute value, then use the sign of the integer with the greater absolute value. So in numbers, that would be 8 plus negative 10 is equal to negative 2, and negative 13 plus 17 is going to be equal to 4. And then over here we have our kind of layman's terms for this. So if we are adding integers and using the same sign, which means we have a positive plus a positive or negative plus a negative, what means we're going to treat it like normal addition, and then we're just going to keep the sign. So if they were both positive before, our answer is going to be positive. Or if they were both negative, we're just going to add them like normal and keep that negative sign. Okay, so we're going to add the absolute values of the numbers and keep the same sign. So positive plus positive is a positive, a negative plus a negative is a negative. Then, if we are adding with different signs, what that means, we're going to be having a positive plus a negative or a negative plus a positive. What we're going to do is we're going to actually treat it like normal subtraction. We're going to subtract the smaller number from the bigger number, and then we're going to keep the sign of the bigger number. So if the bigger number was positive, that means our answer is going to be positive, and if the bigger number was negative, that means our answer is going to be negative. So we're going to subtract the absolute value of the numbers and keep the sign of the bigger number. Okay, so for example number 1 here, we have adding rational numbers. So we're going to be working with these rational numbers right here. Now, because we are adding fractions, what we need to remember is we need to have the same denominator. So we have a 3 and we have a 6 for our denominators right here. We need to find some number that they can both be turned into so that they are the same. So since we have a 3 here, we can multiply 3 by 2 in order to make it 6. And if we do that to the bottom, we also have to do that to the top. So we're going to be multiplying that by 2 as well. So we have a negative, and then we have 8 times 2, which is going to be 16. And that's going to go over 3 times 2, which is 6. And we're going to add that to 8 over 6. Now, because our denominators are now the same, we can just add these numbers together. So we have negative 16/6 plus 8 over 6. Now this negative sign can come up into the numerator right here, and we're going to have an equivalent expression. So negative 16 over 6 plus 8 over 6 is the same thing as negative 16/6 plus 8 over 6. So we have negative 16 plus 8. Since this is a negative and this is a positive number, we can then just treat it like normal subtraction. So we can do 16 minus 8 is just going to be 8. And then because our bigger number, 16, was negative, that means our 8 is also going to be negative. Now, because of addition and subtraction rules of fractions, we're just going to keep our denominator. And so now we have our answer, negative 8 over 6. Now, we do still need to simplify this answer. So as we simplify this answer, what we can do is see that they're both even. So we can divide both top and bottom by 2. And when we do that, we're going to end up with negative 4 all over 3. And then we have our simplified answer. Now, for finding the sum of this second problem, we're going to look at 4 over 5 plus negative 3 over 10. So again, we need to make sure our denominators are the same, And so in order to make our denominators the same, we can multiply this 5 by 2 to make it 10. So then we'd have the same denominators. If we multiply the bottom by 10, we have to multiply the top by 10. So 4 times 2 is going to be 8, and 5 times 2 is going to be 10. And we can add that to negative 3 over 10. Now, as we look at this, we have 8 plus negative 3. And again, because they have different signs, we're just going to treat this like a regular subtraction. So 8 minus 3 is going to give us 5. And our denominator is going to be the same, so that's 10. Now, our 5 is positive because the bigger of these two numbers was positive. It was positive 8 and negative 3. So that means this is a positive 5. And we have our answer. And again, we do need to simplify this answer, and so we can try and figure out what goes into both 5 and 10. So we can divide the top by 5, we can divide the bottom by 5, and we can simplify this down to 1/2. So our final answer is going to be 1/2. For example 2 here, we're going to be adding rational numbers. So we're going to find the sum of negative 4.05 plus 7.62. And we're going to be finding the sum of negative 3.92 plus negative 6.89. So on this first problem here, as we are adding decimals, we need to make sure that we line up our decimal signs or decimal points so that we can make sure to include all of the place values. So we look at this and we see that we have a negative plus a positive. So since they're different signs, what we're going to do is treat these as regular subtraction. We're going to take the smaller number away from the bigger number. So we're going to say 7.62 minus 4.05. Our decimals are lined up, which means all of our place values are lining up correctly. 2 cannot subtract 5, so we're going to borrow. This is going to become 5. This is a 12, so this is going to become 7. 5 minus 0 is 5, bringing down our decimal place, and 7 minus 4 is going to be 3. So our answer is 3.57. Now that we've done this subtraction, we need to come back and check for our signs. So we come up and look at the bigger of the two numbers. It was positive. That means our answer is going to be positive. So our answer is positive 3.57. So we're going to find the sum of this second one here. We see that this is a negative plus a negative, which means we can just treat this like regular addition. So we can say 3.92 plus 6.89, making sure to line up our decimal places so all of our place values line up. 2 plus 9 is going to be 11. Carry that 1. We're going to get 18. Carry that next one. 3 and 1 is 4 plus 6 is 10. So we can go ahead and do 10.81. And now we need to come back and check for our sign. So because both of these were negative and we were adding them together, our sign on our answer is also going to be negative. So real quick on your own, go ahead and find the sum of each of these expressions, and then once you've done that, go ahead and resume the video to see if your understandings and answers line up with mine. So on this first problem, we have negative 7 over 8 plus 1 over 4. We need our common denominator, so we can multiply the bottom by 2 over here and the top by 2 over here. So when we do that, we have negative 7 over 8 plus 2 over 8. So negative 7 plus 2, what we can see here is we are adding numbers with different signs, so we're going to treat this like subtraction. 7 minus 2 is going to be equal to 5, and then because our bigger number 7 was negative, it's going to be a negative 5, and that's going to be over an 8, and so our answer is negative 5/8. For problem number 2, we see we have negative 6 and 1/3 plus 20 over 3. So in order to do this problem, we first need to turn this back into an improper fraction. So we'll do 3 times by 6, which is 18, and 18 plus 1, which is 19. So we have negative 19 over 3 plus 20 over 3. We already have common denominators. We see that it is a negative plus a positive, so we're going to treat it like regular subtraction. And 20 minus 19 is just going to be 1 over 3. And it's a positive 1 because the bigger of these two numbers was positive. So for problem number 3 here, we have 2 plus negative 7 over 2. So the first thing that we have to do is turn this 2 into a fraction, so we can put 2 over 1. And as we do 2 over 1, we can then find our common denominator by multiplying the top and bottom by 2. And when we multiply the top by 2, we're going to end up with 4, and the bottom by 2, we're going to end up with 2. And that's going to be plus the negative 7 over 2. So we can see that they again have different signs, which means we're going to be doing subtraction. 7 minus 4 is going to be equal to 3, and it's a negative number because the negative 7 was larger, so it's negative 3 over 2. As we come over here to the other side, we can see negative 12.5 plus 15.3. They are different signs. We have a negative plus a positive, which means we are going to be doing subtraction. So when we are doing our subtraction, what we're going to be looking for is taking the bigger number, 15.3, and subtracting the smaller number, 12.5, making sure our decimal signs line up. Then we can borrow from here. Go 13 minus 5 is going to be 8. 4 minus 2 is going to be 2, and we're going to end up with 2.8. Then we just need to decide if this is going to be positive or negative. Because our larger number was positive, that means our answer is also going to be positive. Then for negative 8.15 plus negative 4.3, because they are both negative, that means we're just going to treat this like regular addition. So we have 4.3 plus 8.15, and when we see this, we can see our decimal places are lined up, which means we can fill in this hole right here with a 0. So 0 and 5 is going to be 5, 3 and 1 is going to be 4, 4 and 8 is going to be 12. I can bring down my decimal place. So now I have 12.45. And now I need to decide the sign of my answer here, either positive or negative. Looking back up here, I can see that they were both negative, so I'm going to keep the common sign, and my answer is going to be negative 12.45. Then for the last problem here, we have a positive plus a negative, which means, again, we're going to be doing regular subtraction. So we're going to take our bigger number minus our smaller number, so that's going to be 2.75 minus 0.65. As we do that, 5 minus 5 is 0, 7 minus 6 is 1, and 2 minus 0 is 2, so I end up with 2.10. And now I just need to figure out if it's a positive or a negative number. So in order to do that, I check my original numbers to see what the sign of the bigger number was. So 2.75 was negative, so my answer is going to be negative 2.1. For example 3 here, we're going to be evaluating expressions. So our first step in evaluating expression is to plug in the values of the variables that we now have. So we can do 2 times by x, and x has the value of 1/4, so 2 times by 1/4, plus y, and y has the value of negative 3 over 2. So we're going to add negative 3 over 2. And when we multiply 2 times by 1/4, that's going to be the same as 2 over 1 times by 1 over 4. So that's going to be 2 over 4 plus negative 3 over 2. So again, we need common denominators, so I can multiply the bottom over here by 2 and the top over here by 2. So I'm going to have 2 over 4 plus negative 3 times by 2, which is going to be negative 6, all over 2 times 2, which is going to be 4. So now that I have the same denominator, I just check to see that this is positive and this is negative. Since they have different signs, I'm just going to subtract. So 6 minus 2 is going to be 4. Now because 6 was my larger number and it was negative, it will be a negative 4, and it will be over my denominator of 4. So this is my answer right here, but I can in fact simplify negative 4 over 4, and so as I simplify that, it's just going to become negative 1, and my final answer is negative 1. Then, as I look at this next problem right here, I see that I have x plus 2y when x is equal to negative 3.5 and y is equal to 1.7. So again, my first step is to plug in these values that I have for my variables. So x is negative 3.5, and I'm adding negative 3.5 to 2 times by y, which is 1.7. So according to PEMDAS, I need to do multiplication first. So I'm going to take 1.7 and times it by 2. So I have 2 times by 7, which is 14, carry the 1. 1 times by 2, which is 2, plus 1 is going to be 3. And then because I only have one decimal place right there, that means I'm going to bring in my decimal by 1. So my answer is going to be 3.4. So now I have negative 3.5 plus a positive 3.4. So since I'm adding a negative and a positive, what I'm actually going to be doing is subtracting. So I'm going to take the bigger number minus the smaller number, so 3.5 minus 3.4, and that's going to give me 0.1. Now I just need to decide if this 0.1 is positive or negative. So looking back here at my bigger number 3.5, it has a negative sign, so my answer is going to be negative 0.1. For example number 4 here, we have our real-life application. So the table shows the annual profits in billions of dollars of a financial company from 2008 to 2012. Positive numbers represent gains and negative numbers represent losses. Which statement describes the profit over the 5-year period? A gain of $0.3 billion, a gain of $30 million, a loss of $3 million, or a loss of $300 million. To determine whether there was a gain or a loss, find the sum of the profits. So as we look at this, what we're going to do is we are going to add all of these numbers together in order to see if this is in fact going to give us what we are looking for. So as we look at this, we can automatically see we have a negative 1.7 and a positive 1.7. So as we add those two together, that is going to cancel out and we won't have to worry about those two numbers. Then the next step is to see that we have two positive numbers and a negative number. So probably the easiest way to break this into pieces is to add our positive numbers together and then add our negative numbers together. So as we look at this, we can say 0.85 plus 3.6. If we add those together, we can see there's a little hole right here. We have to add in a 0 right there. 5 and 0 is going to be 5. 8 and 6 is going to be 14. Carry that 1, and 1 and 3 is going to be 4. So I end up with 4.45. So I've now used this number and I've used this number, but now I have to add in negative 4.75. So we have 4.45 times by, not times by, plus negative 4.75. So when we see that we are adding a negative and a positive number together, what we're actually going to do is subtract. So I'm taking the bigger number minusing the smaller number. So 4.75 minus 4.45 is going to give me 0.3. So I've now used all my numbers. I figured out that I have 0.3 in billions of dollars, and since it's a positive and a negative over here, I just need to figure out the sign. So my negative number was my bigger number, so that means this is going to be a negative 0.3 loss of billions of dollars. So now we need to interpret this in the context of this problem, this negative $0.3 billion. So when we're looking at this, and for example, if we had $1.3 billion, what that would look like right now is be 1,300, 000, 000. So now this is $1,300,000,000. So if we're just looking at negative 0.3, this 1.3 would just disappear. So we're looking right here at just a $300 million loss, which would bring us down to a loss of $300 million in letter choice D. So for our next real-life application, we're going to be looking at this table, which shows the changes in the value of a stock during 1 week. We're going to find the stock's gain or loss for this week. So again, in order to figure out this, we need to find the sum of all of these numbers right here in order to find that change in value. So the way we can break this into easy pieces to digest is we can look for all of our positive numbers and we can add our positive numbers together, and we can look for all of our negative numbers and we can add all of our negative numbers together. So as we look at this, we can say, okay, I have my 3.45, and to that I'm going to add 29.31. So 5 and 1 is going to be 6, 3 and 4 is going to be 7, and 3 and 9 is going to be 12, carry the 1, and so I'm going to end up with 32.76. And I know my answer is positive because both of these numbers were positive. So I treated it like regular addition, and I'm going to keep the sign. Now for the next problem, I have 12.90 plus 5.02 plus 9.44. So as I add these numbers together, 2 and 4 make 6, and 9 and 4 make 13. Carry that one. 9 and 1 make 10, 12, 17. Carry that one again. I have a 2 right there, so I end up with 27.36. And I know this number is actually going to be negative because all of my numbers over here were negative, so I treated it like regular addition, and then I keep the sign of the terms. So now my next step is to, in fact, add 32.76 and negative 27.36. So I have a positive minus or plus a negative, which means I'm actually going to be performing subtraction. I'm going to take the bigger number minus the smaller number, so I have 32.76 minus 27.36. So 6 minus 6 is going to be 0. 7 minus 3 is going to be 4. 2 minus 7, I can't do that, so I have to borrow, and that becomes a 2, and this is a 12, so this is going to become 5, and 2 minus 2 is 0. So I end up with 5.40. Now, the way that I know this answer is positive is because when I was adding these two together, my bigger number was positive. So I end up with $5.40 as my answer for the change in value of dollars of these stocks over the course of this week. Okay, so go ahead and try these on your own. Find the sum of each of these questions, and then we will go ahead and resume the video, and you will be able to check to see if your understandings match mine and if your answers line up with mine. So we're going to evaluate the expression when a is equal to 1/2 and b is equal to negative 5/2. So what we're first going to do is we're going to plug in these numbers for those variables. So I can say, okay, I have b, which is negative 5/2, plus 4 times by a, which is 1/2. So I can do 4 times by 1/2, which is going to be 2. So I can do negative 5/2 plus 2. And as I look at this, I need to change this into a fraction, so that's going to be 2/1, and I'm going to times this by 2 and this by 2 in order to get them to line up. So I can take this problem right here and I can say negative 5/2 plus 4/2. And now I'm adding a negative and a positive, which means I'm going to treat it like normal subtraction. 5 minus 4 is 1. My bigger number was negative, so my answer is going to be negative 1/2. So my answer is negative 1/2. Then for problem number 8, again, we're going to plug in our values we have for a and for b. So we have the absolute value of a plus absolute value of a plus b. Then we are going to do absolute value of 1/2 plus negative 5/2. So 1/2 plus negative 5/2, we're adding a positive and a negative, so we're going to do regular subtraction. 5 minus 1 is going to be 4. So my answer is going to be absolute value of negative 4/2. So once I have this, I can simplify the inside of this absolute value sign, and it's going to become negative 2. So I have absolute value of negative 2. So my answer is going to be a positive 2. Then the table shows the annual profits in billions of dollars of a financial company from 2008 to 2013, which statement describes the profit over the 6-year period. Well, if you remember this problem, this is the exact same problem that we worked on just a slide or so ago, and we found out that this was going to be a change of negative $0.3 billion. So if we remembered that, we don't really have to rework this part out right here. We just have to add in this last number. So we take this negative 0.3, and we're going to add to that 1.07. So since these are different signs, what we can do is we can treat it like normal subtraction and take 1.07 minus 0.3. So we need to add that 0 to fill that hole. 7 minus 0 is going to be 7. 0 cannot take away 3, so we need to borrow. This is going to become 0. This is going to be 10. 10 minus 3 is going to be 7. And we're going to bring down our decimal place. And so we have 0.77 as our profit over this 6-year period. And this is in billions of dollars. Okay, and this is our mini assessment for today. So we're going to add these numbers together. We're going to write our fractions in simplest form. It is definitely okay to leave those as improper fractions. And for problem number 5, we are going to look at our bank account, and our bank account balance is negative $15.50. And we're going to deposit $75 into our account, and what will be our new balance. So go ahead and work these out, and I'll be checking for these on Friday.